All right, let's get started. Any question before I talk about Lab 5 and also the Lab Practical? Okay, if not, let's get started. So today will be Lab 5, and this Thursday, we will do Lab Practical. Okay, I will talk about more about Lab Practical later today. Now remember, Lab 5 is you need to write a report. Okay, so if you check your Brightspace, there is the formal report guide. So this tell you how to write a formal report. Okay. Ideally, I think we didn't require like in the write-up everything like the equation or the schematic you can do handwrite, but in the report, try to make everything is digital. Okay, so for the schematic, try to build it in LTSpace or some other software and take a screenshot. And also for the equation, try to type it. Okay, try to not like handwrite it and scan it. The report need to be formal. Okay. All right, so let's back to Lab 5. Okay, so today will be the superposition and the equivalent circuit. Since I think most of you should already done the pre-lab, so you should kind of familiar with superposition and the equivalent circuit. There are lots of content in the menu this week, so I may not go through all of them. Just make sure you check the example here. It's a very helpful example. Okay, when you do the superposition, which means you have like multiple voltage source or current source. If you have voltage source, and you will treat it as a short circuit when you do the analysis. When you have a current source, you will treat it as an open circuit. Okay. Okay. Make sure you understand the survey equivalent circuit and the Norton circuit model right here. Okay. And also the voltage buffer. Okay, make sure you understand what is a voltage buffer. We will use voltage buffer in the final project. Okay, so make sure you understand why you need a buffer. Okay, and this week will be the first week you're going to build a ISA chip, which is an integrated circuit on the breadboard. Okay, I will show you how to do that when we talk about the tasks. All right, so let's jump into the tasks. Okay, for the pre-lab question, I saw the pre-lab deadline is actually set at 1:13, so I will talk about the pre-lab question around 1:13. Okay, and then the task 1. Okay, basically task 1, you build the circuit in the pre-lab. Okay, you build the circuit and on the breadboard, and you will similar with the calculation process. So you will take at least I think 4 screenshots. Should have 4 screenshots, and one for 3 of them is for each individual input. Okay, so for V1 have a screenshot, V2 screenshot have a screenshot, V3 also have a screenshot. Okay, when you have the screenshot, make sure you include the input and output. Okay, both input and output, and include the measurement, which is the peak to peak, and also the average. Okay, so all right, so totally 4 screenshot. Each individual voltage input have 3 screenshot, and then the total, like the overall output, have another screenshot. Okay, and ideally, after you make a screenshot, the circuit or the output plot should be similar with what you get from the pre-lab. Okay. And let's jump to the task 4 first. Okay, so the task 4 is you build the circuit from the pre-lab in LT-Spice. Okay, let me open my LT-Spice. Okay, basically you're going to build this circuit right here. Okay, that's the circuit in the pre-lab. One thing might be tricky is wave 2 should be a triangle wave. Okay, so there is no triangle wave in LT-Spice. So you need to use the pulse function to generate a triangle wave, which you set t on to be 0. And that's how you set the triangle wave. And similarly, you should have 4 screenshots. Okay, so V1, V2, V3, individual one, and also the overall one. Okay, I can run my schematic right here. So at the end, like the overall layout should be something looks like this. Okay, so that's what you should get from pre-lab, task 1, and also task 4. Okay, I probably recommend you to do this one first, so you can verify whether you done the task 1 correctly. Okay, there are some common mistake for task 1, okay, or also task 4. Okay, so for example, in task 4, when you measure each individual input, okay, so for example, I treat V1 as my only input. What I need to do is I need to remove my V2 and V3 and then short this to ground. Okay, so that's how you measure the V1 as the only input. Okay, then that's the first output or first screenshot. Then you move this back to here and move V1 and then short here to ground. Okay, so that's how you do the second screenshot, which is V2 as the only voltage source. Okay, so that will be a common mistake in the task 1. Okay, when you build this circuit on the breadboard and when you test V1 as the only voltage source, make sure either you set V2 and V3, which is the sine wave and triangle wave, the voltage source amplitude to be 0. Or probably a more clear way is make sure you connect V2 and V3 to ground. Okay, which means, let me draw this right here really quick. So when you have V1 as your only voltage source, so you have a DC here, V2 and V3, both of them is connected to ground. Okay, then you measure your V out. Okay, so that's called that V out 1. Then after you've done this process, you put for example, you want V2 as your only voltage source, then you need to short V1, V3 to ground. Okay, so sorry, it's not good drawing, but probably you can understand. V1 and V3 need to be ground when V2 is the only voltage source. Okay, so make sure you don't forget this. If you forget to ground the other 2 input, you will get wrong amplitude. Right. Okay, so that's task 1 and task 4. Any question about these 2 tasks? Okay, if not, let's go to task 2. Okay, task 2 is a survey equivalent circuit. which you will need to build this circuit on the breadboard. But before you build the circuit, you need to calculate the value for each component. Okay. The only given number here is the survey equivalent voltage, which is 2.5 volt, and the survey equivalent resistance, which is 1.5 kilo ohm. I have a whiteboard note from previous semester. It's not very good drawing, but probably you can understand the idea. So this is a schematic for the task 2. Okay, so there are two requirements. First one is the RTH, and second one is VTH. So for the RTH, how you can analyze the circuit is something looks like this. Okay, when you remember when you have the voltage source, you can treat it as a short circuit. So you short it here. And then this circuit can simplify to something like this. And when you draw it again, it can draw as this way, which is R3 in series with R1 and R2 in parallel. Okay, so that's the RTH. So this circuit right here should be equal to 1.5 kilo ohm. Okay, so that's RTH. And right here, this is the VTH. Okay, so which means when you still have this circuit right here, when you put a wattmeter right here, you should measure the 2.5 volt here. Okay, so this is exactly same circuit right here, but I just draw in this way for easier understanding. If you have wattmeter here, wattmeter ideally the resistance is very large, so there's no current to go here. So there's no voltage difference at this point and this point. Okay, so which means R3 not affect anything. Only R1 and R2 is affecting the output and all the VS outputs. So at the end, you will have four variables, okay, R1, R2, R3, and also the VS. And you have two equations, okay, one equation according to RTH and another equation according to VTH, okay. Ideally, you can have many answers, okay, but make sure the answer you have the R1, R2, R3, the resistor, you have them in the lab kit. Okay, even you don't have them in the lab kit, you can probably also like put two capacitor in series or in parallel. You can make the capacitor what you want. And another limitation is the VS. Okay, so you can get like many answers for this question, but make sure you know when you build this circuit on the breadboard, the power supply, the VS is from your AD2. So the maximum voltage of AD2 is 5 volt. Okay, so VS need to be smaller or equal to 5 volt. Right, so that's how you do the calculation. After you do the calculation, you will probably build this circuit on the breadboard and verify this circuit is work as you want. Okay, so that's the step number 2. You want to develop a method to measure the survey equivalent circuit for two-terminal network. So first of all, what's the two-terminal network? So something like this is a two-terminal network. Okay, so everything inside here, let's treat it as a black box. Okay, but what you know here is in this black box, you have a RTH and a VTH, which is a voltage source and a resistor in series. But you don't know what's the value here. Okay, the two terminal is this two port or this two pin right here. That's the only two pin you can like connect or measure. So what's the method you need to develop here is in the report, what we want to say is you can write step-by-step method, like step 1, 2, 3, that measure the, let's see, measure the word value for VTH and RTH. Okay, you can either measure the voltage, current, or even the resistance. But at the end, you want to get the RTH and the VTH. Okay. All right, so that's step 2. And then after you get the step 2, you can apply your method to verify your circuit and make sure the RTH is 1.5 kilo ohm and the VTH is 2.5 volts. Okay, so that's task 2. Any question about task 2? Okay, if not, let's go to task 3. Okay, after you build task 2, don't remove your circuit from breadboard. Okay, you will continue use it in task 3. Okay, task 3 is about the buffer. Okay, first of all, what's a buffer? Buffer is a circuit that function to kind of isolate your circuit, but it can also connect them together. What that mean is, for example, you have a large system, okay, and this system have two parts of the circuit, okay. These two parts, if you test them individually, they working correctly. But if you connect them together, sometimes they affect each other. Okay, so in that case, most of the time we can just use a buffer in between. Okay, the issue that have the circuit affect each other is a loading issue. Okay, so that's the case we will need a buffer. Okay, so in step number 1, you replace the VS in figure 5.32, which is this circuit right here, with a AC signal, and then you place a 516 ohm resistor at way out, which means you put your output resistor right here. Okay, so that's a 516 ohm resistor. All right, so that's the step number 2. And then you measure the output. Okay, and then you probably will notice something happened at the output. Then after that, you will remove the 560 ohm resistor and connect the buffer in between. So what the circuit looks like is, one second, is something looks like this. Okay, so you see VS, R1, R2, and R3 is the circuit from your task 2. Okay, so this part is everything from task 2. And then this part right here, that's the buffer. Okay, then you put your 516 ohm resistor at output of the buffer, and then you measure output again. Okay. Okay, so this is the circuit schematic for this this step, and then you measure the amplitude, and you will see a difference for this amplitude and also the amplitude you measure in step number 2. Okay, so let's talk about how to build this circuit on the breadboard. Okay, first of all, what this chip looks like in your lab kit. Okay, so if you check your lab kit, you should see something looks like this. Okay, and make sure when you grab the chip, you see the LF356 on your chip. Okay, so that indicates the part number. Okay, so then you know this is your chip. After you find this chip, you need to know what's the pinout. Okay, so you can find the pinout from the datasheet. Okay. Okay, right here, this is a pinout. If you check on the chip, there are 8 pins. Okay, this diagram show you what's the function of each pin. Okay, and this little notch here, okay, this little half square, that's indicate the orientation. Okay, let me back to the image. Okay, if you see your chip, on your chip, there should be also a little like this half square here that's indicate the orientation. Okay, so you should see your chip exactly at this way. Put this as the top, and then probably the left bottom corner, that pin is pin 4, which is the negative input. Okay, so that's how you check your pin. And here is actually on the datasheet is tell you what's the function of each pin. Okay, so I'm not going to introduce the function here, but I will show you how to do the connection, right? So what you need to do is you want to transfer this circuit schematic, or probably better this one, this circuit schematic. If what you after this lab, what you can do is after you get this schematic, okay, with the IC chip, hopefully you can learn how to build this schematic on the breadboard. Okay, so let's try this together. So what you can do is first of all build this task 2 circuit. Okay, R1, R2, and R3, and remember the at the end, which is R3, that will be the input of the buffer. Okay, so after, okay, so what you need to do is you put this buffer on the breadboard. Okay, so another common mistake is okay, let me show you. Okay, so this is a okay, it's not a very good picture, but I can show you right here. When you get the chip, okay, so you see the chip have 2 column of pin. Okay, so what you need to do is you need put this chip on the gap right here. Okay, so that's how you put your chip. You want to make sure the chip is on the gap of the breadboard. Okay, if you put your chip right here, let's say right here, what will happen is you're shorting the 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 pin that is in the same row. Okay, because if you remember on the breadboard, each row they are shortcut. Okay, make sure you put your chip is on the gap in between. Okay, so that's the first thing you want to pay attention. And then after you put this chip on the breadboard, you can start to do the connection by grab some wires. Okay, usually what I do first is I connect the power supply. Okay, so this is the pin out of the chip. Okay, so if you see this pin 4 and pin 8, I mean pin 4 and pin 7 is the power supply. Okay, if you check the schematic, it's already tell you the power supply, the positive power supply will connect to the positive 5 volt. Okay, which means pin 7 I need to connect to the DC 5 volt power supply, and pin 4, okay, right here, that's the negative power supply if you see on the schematic. So I will connect pin 4 to the negative power supply. Okay, power supply is the very important pin in here. Okay, if you accidentally inverse pin 4 and pin 7, which means you connect the negative power supply to the pin 7 and positive power supply to pin 4, that will burn the chip. Okay, I'm not sure what's happening in the AD2, but if you use benchtop equipment that will make the chip smoke. Okay, if you are using 82, you probably will see a current overflow warning in the software. Okay, make sure pin 4 and pin 7 is connected correctly. Okay, so what I will do is I will build this circuit first, and before I turn on my power supply, I will double check my pin 4 and pin 7. Okay, so when you build this circuit, turn off every uh, power source. Okay. Uh, and then after connect the power supply, I will connect the rest of the pin, which is the input is right here, connect to the positive input. Okay, so that will be pin 3. Okay, I will connect the R3 to the pin 3 of the chip. And then I will connect this line right here. Okay, this line right here. So that's pin 2, okay, which is negative power supply, connect to the output, which is pin 6. So I will grab a wire from the lab kit, connect pin 2 to pin 6. And then the last one is the 516 ohm resistor, which is connected to pin 6. Another side of the resistor will connect to ground. Okay, and then I can measure the way out. All right, so make sure when you build the circuit, turn off all the power supply and double check your circuit before you turn on the power supply. Okay. All right, so that's um, that's all for Lab 5. I will talk about Lab Practical soon. Do you have any question right now? Okay. Uh, I, let's talk about the Lab Practical. Okay. Okay, so as you may noticed, you should already see the okay, Lab Practical in your uh, Brightspace. So this is the Lab Practical. Okay. There are two parts, okay, or two portions. The first portion is the take-home exam portion, okay. Um, so this part you can do it at home at whatever, like whenever time you want, and make sure you finish everything here, okay. And then after you finish this part, okay, so what you will need to do is you submit this part on the Brightspace, okay, to the take-home portion, and then you should able to see there is a quiz here. Okay, so this quiz is actually just a true/false question. Okay, so this quiz is telling you what's the value you will need to use for R load and what's the value you need for this R equivalent, and also this circuit diagram will be given. Okay, so that's a quiz. Uh, so after you open the quiz, make sure either you take a note about the value you're going to use or take a screenshot, okay, in case you forget it afterward. Okay, so after you submit the takeout portion and you get the value for the R lot and this task, you have 2 hours to finish the in-lab portion, okay? So make sure you submit. We will check the submit time of your take home portion. Okay, so after 2 hours, if you haven't submit your uh in lab portion, that will count late as your uh in lab portion. Okay. All right. So first of all, each student have different value for those value right here. Okay, so in the green box, so you need a value given by us. I will post the value you need on the Brightspace. Okay, so what you will get is a version number. Okay, so the version is from number 1 to number 10. Okay, you can find it on your grid. Under your grid, there's the LP version number. So that's a lab practical version number. I will post it after this class. So you will find your version number and you will find what's the value you need in this document. Okay. All right, let's go through the tasks really quick. Okay, so for the task 1, you're going to draw the circuit model. Okay, so make sure you understand here is draw the circuit model, not the circuit symbol. Okay, and in this question right here, it's asking you to use only multiple of 10. So actually, if you're using like 2.5 or 5 words division, that's also fine. That's also count 10 words, multiple of 10, but just don't use like fractions, like probably like 1.3 or 1.7. Okay, that's not okay. And this question right here, that's kind of relate to Lab 5, the survey equivalent circuit. Okay, make sure you understand what's survey equivalent circuit and how to calculate it. Then you can do this question. Okay, and then the in-lab portion. This first question, you're going to use LT-SPICE to do the simulation. Make sure you take a screenshot, okay, since we are not going to check it in person. So make sure you take a screenshot of your circuit and also the result. And then you build the circuit on the breadboard and measure the value you need. And make sure you take picture of your breadboard. Okay. And then, okay, this question also make sure you take a picture. And then the step number 2 in the last task, that's a mystery signal, which you did something similar, I think in lab 3 or lab 4. Okay, so you know how to open the mystery signal. Okay, the mystery signal document will be given after you submit the take-home portion. Okay. And also for last task, make sure you take a screenshot for each steps. Okay. All right. I think that's all for lab practical. I think the deadline for the lab report is this Friday. Okay, so try to finish the lab 5 first, and then you can start the lab 6, which is a practical. And make sure you practice everything by yourself. Okay, so what you can do is before we give you the number, try to try to like put a number here by yourself and do everything first. Yeah, the lab practical, I mean the lab report is due at Friday midnight. Okay. Yeah, just make sure when you're doing the real practical, it's not the first time you build this circuit. Okay. Um, and I think the lab practical is due next Tuesday midnight. Okay. So you have 2 hours to finish the take-home portion, which means at least the take-home portion you need to submit like 10 p.m. at next Tuesday. All right, I think that's all for today. I think we should already finish the gradient for lab 1 and lab 2. Hopefully we will finish the gradient for lab 3. Yes, so yeah, there are only 2 hours for the take-home portion. Okay, so after you submit the in-lab portion, the take-home portion start to count. Okay, the time start to count. And okay, so another thing here, you can submit whatever format you want. Okay, you can either print the lab practical and write down on the paper and scan it, or if you are more comfortable with iPad or whatever you want, as long as the answer is clear to say. Okay. This Thursday is actually the lab for the lab practical, but the deadline is next Tuesday.
Wait, so just to confirm, we
Yeah.
have to complete the uh take home and in-lab portion within 2 hours, starting from Thursday to next Tuesday. So we have
No. The take home portion. Okay, the take home portion you can do it whenever you want. There's no time limitation. For the okay, as after you finish the take home portion, you scan it or you save it as PDF and then you submit on the Brightspace. Okay, as long as you click the submit button, that's the 2 hours start to count for the in-lab portion. Okay. So you have 2 hours for the in-lab portion. No, for the take-home portion, there is no time limitation. Is that clear?
But like once
yeah,
that
and
starts, at the end of that, do we have to have the report submitted, or is that just the data?
No. There's no report or write-up for lab practical. Okay, the report is only for Lab 5. The practical, as long as you finish every question on the practical itself, so that's all. Any other questions?
so after we submit the take home portion,
Yeah.
we submit it. We have 2 hours to do the in-lab portion, and that
Yeah.
one must be submitted before 10 p.m. on Tuesday.
Yeah, because the reason I say the 10 p.m. on Tuesday because the overall deadline for the lab practical is Tuesday midnight. So if you want to like enough 2 hours to do everything for lab practical, I mean for the take home portion, I mean in lab portion, then you need to submit the take home portion before 10 p.m. Yeah, for example, if you submit your uh, take home portion at this Sunday, 3 p.m. Okay, then you need to submit your inline portion before 5 p.m. this Sunday.
We're doing the in lab portion in like during 11 a.m. to 2 p.m. something like that.
No. In the inline portion, you can do it whenever you want. So it's overall it's a take home exam. So I will still be here on Thursday. So since Thursday is a lab practical in the normal semester, so I will still be in my WebEx soon, but it probably will be like office hour. So if you have any question, you can come here to ask. Any other questions?
I don't get what the lab practical really is. Is it like an exam or like?
Yeah, it's like a small exam. Let me probably I can share my screen again. Yeah, so this is lab practical. Okay, so it's already this document you can find it on the Brightspace already. So so you need to answer each question right here. So that's kind of like a small exam here. But there are two parts. Okay, so the first part is the take-home exam portion. So that part you can do it like whenever you want, and also there is no time limitation. Okay. And then there's another part. Okay, so that's part. The first time part take-home portion is 25% of the overall grade. Okay, and then the in-lab portion is 75% of the overall grade. And for this part, you have 2 hours to finish it. Okay, so after you submit the take-home portion, the time start to count. You have 2 hours to finish the in-lab portion.
Are we gonna have to use the 82 for in lab portion
Yeah, you will use 82. Yeah, for
for the
the
mystery signal, right?
yes.
Oh, so you're saying the exam version values will like open up after you're done the take-home portion?
Yeah. I will post it after this class. For the take-home portion, I will post it. Okay, for the green box, I will post it after this class. But for the in-lab portion, okay, this green box, that's posted in the quiz. Okay, after you submit the take-home portion.
Is there like a this? I mean, it's not really related, I guess, but is there like a tutorial to how to do like the mystery signal stuff? Because for the lab that we had to do, I didn't have my 82 yet, and I had to run an LT
Okay.
Spice.
I can. Yeah, there's no not a very. I can't directly show you how to open the signal in the lab 6. I mean, not lab 4. I mean, 1 second. Let me open my WinForm.
Should I review the lab 4 documentations?
You can try that. It's actually given in the document of lab 4, but I can't directly show you right now.
Okay, thank you.
Do we have break room today?
Sorry, what's that? Do we have what?
Break room.
Yeah, we will. I will assign break room soon. Let me show this. I will. Okay, so this is your waveform. Okay, so the mystery signal. You will need to open your this function here pattern. Okay, so after you open the mystery signal right here, there are 2 pins. You see here the IO0 and IO1. So that's the digital IO pin 0. So that means the signal is coming from the pin 0 of your 82. Okay, and also this signal is coming from the pin 1 of your 82. So when you measure these two signals, you want to make sure your oscilloscope connect to the pin 0 and pin 1. Okay, so it's a very simple process.
Okay, thank you.
Yeah. Okay, so there are a couple of things for the practical. First of all, make sure you sort the resistor properly. Okay, what I mean is, like we will give you random resistor value at the beginning of the lab practical, right? So it will take a little bit time to find the resistor. But if you sort your resistor value like before the practical start, it will save you time to find the resistor. Okay. And also, if you're like just get AD2 like or probably last week or your lab kit last week, make sure you understand each function of AD2 and also make sure you understand how the variable work. Okay. Overall, just make sure you practice everything or every question on the lab practical by yourself before you start the actual practical. Okay, I just started the breakout session. So if you have any questions, want one-on-one help, you can go to the breakout session. There is a question about the pre-lab. Okay. The step number 4 is actually you watch this video right here. So if you open on YouTube, so it's right here. You repeat the same process. There should be a DC simulation. There is a transient simulation. Okay, the first one is called operating point simulation. Second one is a transient simulation. You repeat the same process, then you get the result and take a screenshot. Okay, let's go through the pre-lab really quick since it's the due time of the pre-lab. Okay, so first of all, so this is the schematic of the pre-lab. Okay, so as you noticed, for the superposition, you will have multiple voltage source or multiple power source. When you do the calculation, you just take one of the voltage source, treat that as your only voltage source, and short other two. Okay, so which will transfer the circuit to be something like this. Okay, for example, if your V1, okay, the DC1 is the only voltage source, what will happen is V1 is your only voltage source. You will short V2 to be ground, and also V3 to be ground. So that will transfer the circuit to something looks like this. Okay, this one, which is R1 in series with R2, R3, and R4 in parallel. Okay. Okay, so that's what will happen. This circuit right here is for the V2. So for example, if your V2 is the only voltage source. Okay, that will be R1 in series with R2 in series with R1, R3, and R4 in parallel. Okay, so that will simplify this circuit to be a voltage divider circuit. Okay, which is the total resistance is R2 plus R1, 3, 4 in parallel. Okay, that's the total resistance. And the output is way out 2 here. Okay, so then the output is on numerator. Okay, then times V2. V2 is the only input here. So that will be the way out 2. Okay, so you repeat the same process to calculate way out 1, way out 2, and way out 3. Okay, so if you plus them together, that will be your total way out. Okay, so since way 1 is a DC, so way out 1 will be a DC signal. Okay, it should be a constant number. Way 2 is a triangle wave, so way 2 is an equation of triangle wave. Okay, and way 3 is a sine wave. Okay, so which means the final answer is a DC plus a triangle wave plus a sine wave. Okay, then you use this equation to plot the output. So that's, I think, second step or third step in the pre-lab.